And from testing, what I have seen is that you saw these concrete cones earlier. Concrete cones, if you use double studs, then concrete cone is shared between those studs. The failure is mainly concrete in case of profile sheeting slabs. So when they are shared, then obviously the size of cone reduces, unless if you have a lots of gap between those studs, which is not possible because width of the top flange is limited. That's the reason we have less load per stud in case of double studs and about 30% less. In case of single studs, we have more. Yes, how do we determine shear connection? Yes. So we ensure shear connection in beams by using these shear studs, and headed shear studs are the most common one. And these are typical properties of these studs: 450 Newton per millimeter square, elongation is 15%. They are very quick to weld and they are strong in all directions. This is very important. So in case of load reversal or in case of other loading, the beauty of these studs, round headed shear studs, is that they are equally strong in all directions. So in buildings, almost certainly you will use headed shear studs. A small replica of beam tests, they are carried out to assess shear connector resistance to longitudinal shear. And these tests, they look like this. In design codes, we have push tests which are for solid slabs, and in design codes they say that they should at least have 6 millimeter slip. Surprisingly, no design codes, Americans included, will give you any push test for profile sheeting slabs. They say that you should use the same configuration, but they don't specifically give you any guidelines for profile sheeting slabs. And in profile sheeting slabs, you will not have this 6 millimeter slip for ductile failure. Now, does this mean that in profile sheeting slabs, when we use shear studs, they are not ductile? The answer is no, because when we use sheeting in a push test, it applies direct shear, but in case of beams, direct shear is not applied. When we apply loading, the load is vertical and then it is transferred in horizontal direction. And also flexure of beams, it will help as well. So mostly the failure is gradual. So in beam you will have this slip which is far more than 6 millimeter, but in testing for profile sheeting slabs you will not have 6 millimeter. And to account for that, we did lots of testing. I did testing in horizontal direction as well. So this is testing in vertical direction. For composite slabs with profile sheeting, there's no standard test in any design code. They've been trying to build some, but they couldn't get it. And we apply a reduction factor approach. So we work out the shear connected capacity for solid slabs, and then we apply that reduction factor. First of all, we find out shear connector capacity for solid slabs, and then we work out reduction factor for profile sheeting slabs, and then we apply those reduction factors. Most design codes, they apply reduction factors to shear studs strength from solid slabs. This is the configuration for profile sheeting slabs. As you can see that in vertical direction we have a beam, on two sides we have profile sheeting slabs, and this configuration does not really work properly. So we thought to have a horizontal profile sheeting. This was the configuration. So this is one of my PhD work, and I have one research paper, in fact 4 or 5 research papers from this research, that we conducted this testing in horizontal direction and single-sided direction. So this is about 1.5 meter long slab in each direction, and we applied loading over here. And the purpose was to see that if we are getting this slip which is not less than 6 millimeter. And these are some failure modes. So the failure happened by rotation of last stud. So this was loading direction, or in some cases this stud was taken away from there, and the failure happened due to conical failure. So these concrete cones were formed around shear studs. Now remember this concept. I will ask you a question in a minute, that why these concrete cones they develop. And then we remove this slab from top of the profile sheeting. You can see that this is the first stud. You can see cones are quite a lot, and the bottom one, for not bottom, the last one, it is actually the stud is taken away from the, is blown away from concrete, from a steel beam, and then last rib it rotated. Looking at here, the stud strength is divided by, there are 5 studs, 1 2 3 4 5, and we divide everything by 5. But looking at these cones, the cones do not match. The one which is near to loading, it is taking a lot of load. But again, this is the convention that we have been using in design codes, that we say that this is the stud strength. Now this is how we got shear stud strength. You can see here that stud strength is about 70%. In design codes, what they do is that they carry out lots of testing, and they figure out what is shear stud strength, and they apply partial factors, and after applying partial factors it comes out to be about 55 something. So that's how they do it in design codes. Surprisingly, here you can see that at 6 millimeter slip the load is dropping. In Eurocode it's a requirement that the studs should at least have 6 millimeter slip. But in whatever testing is done across the world, America, Australia, everywhere, this 6 millimeter is not obtained. And many researchers, they give this reason, is that because this testing applies direct shear in real life, when we have a composite slab on top of the beam, flexure of beam itself, it helps. So the failure is gradual. In that case, the slip does not happen until probably 10, 15, 20 millimeter. So this requirement is met in case of beams. But these short tests, they don't fulfill this requirement, which means that we should have some different kind of testing for steel concrete composite beams with profile sheeting. Single stud per rib and double stud per rib. Single stud per rib, you can see that we have 70 kilonewton per stud, and here we have about 50, on average about 50 kilonewton. Why this capacity is less? If we have double studs, then certainly we should have more capacity. This is how it makes sense. But in case of double studs, the capacity per stud is reduced. What is the reason? What could be the reason? And from testing, what I have seen is that you saw these concrete cones earlier. Concrete cones, if you use double studs, then concrete cone is shared between those studs. The failure is mainly concrete in case of profile sheeting slabs. So when they are shared, then obviously the size of cone reduces, unless if you have a lots of gap between those studs, which is not possible because width of the top flange is limited. That's the reason we have less load per stud in case of double studs, and about 30% less. In case of single studs, we have more. Okay, now I have a question for you. Have you ever used push-out test data or relied on design codes to determine shear stud strength? I think another surprising thing, Bhavan, is that these design codes, they were developed for 50 to 80 millimeter deep decks. But nowadays we have decks which are 100 and 150. Kingspan has 146. So when we use these design formula now in American or Eurocode design codes for deep deck, they give wrong values. So manufacturers, they have to provide these shear stud strength.
And always, this is one of the gray area I have seen that now what shall be the spacing of the shear studs, which is being identified in the drawings. So, so as you rightly said,
Yes,
it may be placed just maybe on a thumb rule basis or as an empirical formula basis. But as you rightly said, more details are required for this. Okay, some
definitely.
comment has come here. Yeah, no, we use the
We
data
use
provided
limit.
by the manufacturer. Yeah. I think that's a common practice in India, if I'm not wrong. Mostly, we are dependent upon the data which is provided by the manufacturer.
I think here in the UK as well, they use manufacturers' data. But in my view, there should always be some kind of design code or some guidelines which we can follow to independently verify. Because manufacturers, I have worked with manufacturers. What they do is that they just test one-off tests, and based on those tests, they have one value. So how about if that experimental value could be wrong? So I think it should be number of studies, it should be hundreds of testing before we can come up with any design formula, isn't it?
Alan is saying that he has used it, right?
Okay, excellent.
Okay,
Let's
Muhammad is interface share.
interface here.
Yeah.